a look at this first question. It's loading up there. There it is. It says the length of line segment AB is 380. The length of line segment CD is 95% the length of line segment AB. So what I want you to think about or ask yourself is CD shorter than AB or longer than AB?
Shorter.
Shorter. So that right away actually tells you that, well, these two are for sure out. Okay. And then the question is, well, which one is it? And you could grab a calculator and you could do 0.95 of 380, but you might look at the answers and say, well, is there one that stands out more than the other? Like, meaning it's kind of close to 380, but not exactly 380. And you can see the answer would be, in this case, 360.
Okay.
And the reason is again, is that there's this, it's really close. 285 is way too small compared to that. And I guess it really comes down to your comfort level with, percentages and decimals and things like that. All right. So let's look at another question here. Any questions on that one though, before I go?
No.
Okay. This is the tip question. Okay. So a waiter receives tips from each customer. On average, the tip is 15% of the customer's bill. At this rate, which of the following is closest to the tip the waiter can expect when a customer has a bill that is $78.20? So there's a key word here that says closest to. All right. And in the previous problem, it actually said, it didn't say it, but you're looking for words like that. And that means you're going to estimate. Like, you don't have to get the exact value. All right. And so again, like, you could go to a calculator and do 0.15 times 78.20. But the idea is you actually can do it without grabbing the calculator, and you can do it faster this way. So do any of these numbers stand out to you as either being right or wrong or different or, close to the answer? Anything stand out to you when you look at these four answers?
I think 8 and 10 to be the closest ones.
Okay, so eight would be 10%. Okay, and so 15% is well, what's another 5%? Basically 5% is half of 8. Half of 8 is 4. So when you add these together, right, 10% and 5% is 15%. 8 plus 4 is 12.
Okay.
Okay, so this is where this is. So let's look at one more question here, then I'll give you a little more math background before we have you try some. So here's another question to look at. And this is a legitimate SAT question. It's not hard, but it is a question where you really do need to know your things, your percentages, like which one is the top number, which is the bottom. Okay.
Okay.
So it says, what percentage of 40 is 15? And it might be better to look at this as 15 out of or 15 over 40. Okay. And you can eliminate, I think, a couple of answers here, because 15 out of 40 is closer to the middle. So it's definitely not D and definitely not A, but is it B or is it C? And that's where this estimation technique only goes so far. Any idea how to answer this, or how to go from without grabbing for a calculator, how you might figure this out?
No, I don't know.
So how would you go to 100 from 80? What would you do? What would you multiply by?
You would add 20 or
Times 2, but then it need a little more than that, because that gets you to 80.
and then
0.5. Okay, so like, because 40 doubled is 80, and then half of if you take half of 40, that's another 20. That's where the 20 comes in. Okay, so now you've got to take 15 and multiply by 2.5. Okay.
okay.
So, and you can grab a calculator if you want, but see if you could also try and do it by hand. 15 times 2 and then 15 times a half. That will give you one of these numbers here.
37.5.
Yes, very good. Very good. Okay. And so this is where I'm going to go into just a tiny bit of teaching before we do some more problems. So there's tips and taxes, and then there's discounts, and we're going to talk about each of those for the moment here. So you've been to a restaurant. Let's just say you wanted to leave a 10% tip on a bill. Let's say the bill was it's an expensive meal. It was $85. Can you tell me what 10% of $85 is?
8.5.
8.5. Yeah, so it's $8.50. Notice you just moved the decimal one place for 10%. Now, that's the tip. What you end up paying is 85 plus the 8.5. Okay. Now, in terms of percents, it's 100% plus the 10%. So you end up paying 110% of the bill. Is that clear?
Yes.
So tip slash taxes, they increase it. They're greater than 100%. Discounts are different. Okay. So you go to a store, and let's say you want to buy something that's $60, but it's 15% off. Okay. So here's what that means. Well, if we take 10% of 60, that's 6, and then 5% of 60, that's half of 6, that's 3. That's $9 off. Okay. But when you get a discount, there's two things it could be asking you for. It could be asking you for the discount, but it could also be asking for the actual sale price. The sale price in this case is 60 minus 9 or 51. Okay. Now in terms of percents, that's 85%.
Could you explain it again, please?
Yeah, sure. So we got to start with the idea that one direction increases and the other direction decreases. Okay.
Right.
Right.
Okay.
So now let's I think the discounts are the one that's unclear. So what is let's say you were going to Disney, and I think the tickets are pretty expensive now. Let's just say it's $150, but you have a 10% off coupon. Okay. If you have a 10% off coupon, the first question they could ask you is, what is the discount? And the discount is 10% of 150. How much is 10% of 150?
15.
15. Okay. So the discount is 15. The second question is, what do you end up paying? And you pay the original price minus the discount.
Right. Okay.
Okay. Now I want you to go to a calculator. If you do have one handy,
Yes.
and do 135 divided by 150.
0.9.
0.9. Now that shouldn't surprise you because it was 10% off. 10% off means 100% minus the 10%, which is 90%.
Right.
So let's do another example here. Let's say there's something at the mall. You find a new shirt that you really like, and it's $24. Okay, but you have a 20% off coupon. Okay, 20% off coupon. So there's two ways you could look at this. You could do like we just did, which is calculate the discount. Okay, or you could realize that you're going to pay 80% of 24.
Right. Okay.
Okay, now it's up to you. Now, a lot of students like to use the discount method, like they like to calculate 20% of 24. Okay, which ends up being $4.80. But you then have to subtract that from the original price, and that gives you $19.20, or you can do 0.8 times 24 to get the same number.
Right, okay.
Okay, now, and so if you've ever been somewhere where they calculate the new price real quickly, that's what they're doing on the right. They're taking that original price and multiplying it by 0.8 or whatever it is that you're paying. Okay. So they give you the same thing, but what you need to, what I'm trying to summarize here is that you end up getting 100% is sort of the original. And so if the new price is greater, then it's going to be greater than 100%. If the new price is less, it's going to be less than 100%.
Right, okay.
Is that clear?
Yes, thank you.
Okay. Now I'm gonna talk about the rule of 10, but I'm gonna do it. Let me try it. So, well, let's just try one. Let's just see here. So here's a new question for you to think about and try on your own. And take a look at this. Let me know what you come up with. And we'll discuss it here in a moment.
Okay. Is it C?
The answer is C. So I want to talk about what I call the rule of 10, and it's related to percentages. So 10% is really easy for most people. What is 10% of 800?
80.
80. Now 5% is really half of 10%. So that's going to be half of 80, which is 40. Do you agree with that? Do you see that?
Yes.
Okay. Now, this one is increased. So it's more increased. So right away, well, all these are bigger, but you might realize that I mean, there's a reason some of these are here, but you know that it goes up, so you can remove some of them. So yeah, the answer is letter C. Okay. And did you do that with or without a calculator? It's okay.
With
Okay. Try it's okay if you want to use it. Like I not all of these though are in the calculator section. And I made the point, just gonna forget because I didn't have my notes, but like most of the calculator problems can actually be done without a calculator. And the calculator will potentially slow you down. But I mean, it's okay if you want to use it. I'm not like gonna have any negative ill will or anything. I just want you to try some without it. Maybe the compromise is you try it without and then check with the calculator after you're done before you give me your answer. But take a look
Okay.
at this problem and see what you come up with.
Um, I'm not sure. Is this one,
So what if I told you this is just asking for 12 divided by 50? How could you answer it now? Could you?
um, then it's B.
Yes. Very good. What was hanging you up on your original look at the problem?
I was doing 50 divided by 12.
Okay. So you always want to think of percentages as part to whole, part to whole. But like you just like the number you just got, they're not always, and we talked about this earlier, it's not always just like less than 100%. So here's another problem for you to think about here. And again, this is a legitimate question that you might see. What is 120% of 2000? And first thing you might want to think about here is the result bigger or smaller than 2000?
Bigger.
Yes. So that means you can eliminate a couple of answers pretty darn quick without having to do much work.
Is it C?
It is C. Yeah. Now using that rule of 10 again, just talk about that here. 10% of 2000 is 200. Do you agree with that?
Yes.
Okay. So 20%, you can think of it two ways. It's either double 200 or it's another 10%. Okay. But in this case, that's 400. But you don't want that. You want 120%. So you got to account for the original. That's why C is correct. Okay.
Okay.
All right. So here is another problem for you to look at. It's more like the one we did 2 problems ago. So take a look at that. And I'm just going to step away for 30 seconds, but I'll be right back.
Okay.
How are you doing on this one?
Um, I think good. Is it letter D?
Okay. How did you come up with D?
Um, doing 5 divided by 11.
Okay. And that is letter D, but it's asking of the participants. So these are the people that were selected at random. So how many of those gave a rating of 5?
2.
2. 1, 2. Okay, so that's 2 out of 11. Now, in terms of estimation, because it says closest to,
All right.
okay, because it says closest to, you want to think of 11 as being about 10. So what's 2 out of 10?
0.2.
Yes, or 20, or about 20%, or letter B.
Okay.
Okay, so let's look at another problem here. That's the estimation part of this. Like if it asked for the I don't know, closest to a rating of 9, how would that change your answer here? this time. And actually, let me reset the problem here and just change that number to 9.
Then would it be C?
Yes, very good. Okay, again, no calculator needed for this. All right. Okay, so this one's a little bit more difficult. It's another estimation problem. Really, it's really meant to be done without the calculator, but let's work it together. I actually put up a question kind of like this on social media today, so we'll look at that one next. Let's look at it together. So at Lincoln High School, approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted into the National Honor Society last year. If there were 562 juniors and 602 seniors enrolled at Lincoln High School last year, which of the following is the closest to the total number of juniors and seniors at Lincoln High School last year who were inducted into the National Honor Society? So what I'd like you to do is tell me what this question is asking for. And if you need to read it again, please do. Let's just see how comfortable you are with analyzing what it's asking for.
It's the juniors and seniors who are in National Honor Society.
Yes, yes. So it's 7% or 0.07 of which number?
Of 562.
Yes. Okay, now using the rule of 10 here, because let's just say we don't have a calculator, I want you to think of this as really 5% plus 1% plus 1%. Okay, so and 5% comes from 10%. So everything comes from 10%. So what is 10% of 562 roughly?
56%.
56. So we'll say 56. Now 1% of 562 is 10% of 10%. So we'll call that 6-ish. Is that okay?
Okay.
All right. Now we also want 5%. Okay. So 5% of 562 is going to be half the 56. Half the 56 is 28. So now we can use these numbers: 28, 6, and 6. How many students is that?
40.
40. And we know we're going to add to it because we got to do the other group. So that means that C and D are out for sure. Okay. And that's again, we talked about that strategy. If you can eliminate answers, you should do it right away. Now, 5% of 602. Okay. Well, so to do that, let's first figure out what is 10% of 602 roughly.
60.
60. So what is half of 60 for 5%?
30.
30. So it's 30 plus the 40. How many is that?
70.
70. So what would be your answer?
B.
B. Good. All right. Now I put one up on Instagram. It's a little bit more difficult than this, I think, but it's the same. It's almost the exact same style of question. I just tried to make it a little bit more wordy. So take a look at this. See if you like it. If you're not following me on Instagram, I do post a lot of questions there and some other stuff. Math. It's all math related. It's not me. It's the business. So why don't you take a look at this one?
Okay. So for this one, for the juniors, would it be 35?
Roughly, yeah.
And then the seniors, would it be like 60?
Maybe a little more because the 11% kind of jumps it up just a tiny bit more.
Oh. Would it be B?
It would. It's good if you're since you're able to do that on your own. I would say you definitely understand this topic. So that's awesome. All right, let's transition topics because I'll probably put you to sleep if we keep doing percentages. Let's move to quadratic formula. So do you remember quadratic formula from previous class?
Yes.
Okay. Now, there's variations on this, but the first example we'll do is literally just it's literally just a quadratic formula. Okay. So I'll work this out with you just so you can see. You have to label A, B, and C. Okay. And then you have to remember it minus B plus or minus the square root of B squared minus 4AC all over 2A.
Right.
Okay. So one of the things I tell students, and I strongly recommend this, is you substitute in parentheses, especially for the negative value. Sorry. So it'd be -7 plus or minus the square root of parentheses -7 squared minus 4. And then when I'm multiplying, I also always put in parentheses. That way I don't miss a sign. It's so easy to miss a sign. Okay.
Okay.
Now again, just test taking strategy stuff we've talked about over and over again. What is the result of this thing in green?
It become positive.
So notice that A and B have positive and C and D do not. So they are out. Okay.
Right.
And then notice the next difference between them is what's inside the root. Okay, so it's not like your traditional algebra, algebra 1, algebra 2, where you have to actually give an answer here. You just need to figure out what's different. So inside the root, you square, so that becomes 49. 4 times 3 times -1 inside parentheses there is -12, but there's already a negative, so it becomes plus 12. So you can see that it is 61.
Okay.
Okay. Now you might think, oh, I've got it, and you probably do. But let's have you try one on your own and see if you understand that there is legitimately just questions that ask you straight up to solve this, but then they do get more difficult. So we'll look at those as well. So go ahead and try this one on your own and let me know what you come up with.
Okay. Is it B?
Okay, how confident are you in your answer?
Sort of.
Sort of confident. Okay, so this one is kind of a little more difficult because you do have to reduce the root this time. So that's 6 squared minus 4 times 4 times 1 all over 2 times 4. So it's for sure either A or B because that -3 out in front. Inside the root becomes 36 minus 16, so it's the square root of 50. And I think we have talked about reducing roots a little bit, but hopefully that wasn't too challenging for you. Um, when you get the square root of 50, by the way, did you get square root of 50? I should have asked that there. I'm sorry, did you say yes? Cut out.
Yes.
Awesome. Okay, so what you do with the square root of 50 is you use a prime factorization, 2 and 25, 5 and 5. So the pairs come out. So a 5 is going to come out here. So it's going to be, sorry, this is not looking right. Sorry, it's the square root of 20, not 50. I don't know why I said that. 20. Really, really, really bad. Square root of 20, 2 and 10, and then 2 and 5. So the 2's come out, and the square root of 5 is left over. So the square root of this becomes -6 plus or minus 2 square root 5 over 8. And this for me would tell me that it was actually letter A because of the square root of 5. So we should maybe talk a moment about reducing roots if that part is still unclear.
Yes, please.
Okay, let's do that real quick. So let's look at something much simpler like the square root of 12. So you start with prime numbers, prime factorization, factor ladder, and the prime numbers are 2, 3, 5, 7, and so on. Start with 2. Does 2 go into 12? Absolutely. It's 2 times 6. And then it's 2 times 3.
Right.
So you bring a 2 out, a 3 in.
Okay.
So that's 2 square root of 3.
Got it.
All right, so now let's look at, let's do like the square root of 28. 2 and 14, 2 and 7. Again, you have numbers you bring out, or you bring a number out, which in this case is a 2. The 7 stays in, okay? And you end up getting 2 square root of 7.
Okay. Got it.
Okay. Now there's other problems you might see, like let's say it asks for the square root of 18. 2 works, and that's 9. But then you stop trying 2, you go to the next prime number 3, and 3 does work, 3 and 3. So this time the 3's come out, a 3 comes out, but that 2 stays in. So whatever you have a pair, the pairs come out. So it's 3 square root 2 in this case.
Okay. Got it.
So let's have you try this one, square root of 45, please. Now, wait a second. That's not a good one for me to give you. Sorry, I'm trying to think too hard about this. How about the square root of 98? That would be a better one.
Okay. It would be 7√2.
Yeah, 7√2. Good. Okay. Another possibility is you get a scenario where the and I'll do it with this one, the square root of 72. You can have more than one pair. So there's 2 and 36, 2 and 18, 2 and 9, 3 and 3. So this for this problem, there's a 2 is going to come out and a 3 is going to come out. But the 2 here is going to stay inside here.
Okay. And then
So it'd be 2 times 3 square root of 2. What is your question?
sorry, I was gonna say, can you multiply them once they're
Yes.
out?
Yes, good question. Because like, what do I do with the numbers? Like yes, they are multiplied.
Okay.
All right, so let's see here. Let me try to think of one here. How about you try this one for me, please?
Okay. And then so 4√3.
Yes, perfect. Very good. Okay. So this one, I would like you to use the quadratic formula and work it as far as you can on, and then we'll look at the rest of the question together.
Okay. Um okay, so 2 plus or minus the square root of 8/2.
Like this.
Yes.
Can you reduce the square root part?
Yes. So can you add
Say,
what you
say it. I didn't. I'm sorry. Just if you could repeat that.
um when you take stuff out, can you add it to the other two?
It's just gonna, just for the moment, just focus on this, and then I'll show you what to do from here. Um,
Okay.
what does that reduce to?
2 plus or minus 2√2
Good.
over.
Yeah. So to answer your question is you divide each of them by the 2.
Okay.
So this becomes 1 plus or minus the square root of 2.
Okay.
Okay. Now we're gonna look at the full question together here. You've done most of the heavy lifting here. So it's the same thing, but it gives you a little more. So let me again, but write out that we know that x equals 1 plus or minus the square root of 2. Okay, that we found that solution. The equation above has solutions x equals n plus square root of k and x equals n minus square root of k, where n and k are positive integers. What is the value of n plus k? Can you tell me the value of n from the highlighted here in green? What is n?
1
1. And what about k?
as 2.
2. Can you add 1 plus 2?
Yes.
So it appears to be this really difficult question, but it actually is not. It's just an issue of getting comfortable with the idea that you have to add the solutions together.
Right. Okay.
So what, or add this n and k together. So the extension of this, so the extension of this is every single problem, quadratic problem, is written like this. It's n plus or minus the square root of k. And if you take the two solutions, n plus the square root of k plus n minus the square root of k. So think of this as x1 and this as x2. If you add these together, what do you see that cancels each time?
The square root k.
Yeah, that part. So like the question, there's a question here, and it's really not a hard question, but it's like, if you know this thing about solutions, the solutions add up to like whatever this thing is in front. Now, what is that thing in front? I'm kind of shortcutting here, but it's the minus b over 2a. But you have to double it because that's the 2n. N plus n is 2n. So the point is that you can actually really shortcut your time here if you know this shortcut, which is that the sum of the solutions is minus b over a, which in this case is minus a minus 6 over 1, or 6.
Okay. Right.
And that's a pretty big deal to be able to shortcut that. So just because we are running out of time here, I'll just have you try one more here, just a straight solving the quadratic here, and we'll close out with this problem.
Okay. Um,
How are you doing on this one?
Good. Almost done.
No, one thing you can for sure do is eliminate C and D, and I would certainly do that to get yourself down to 2. Inside the root there is 144 minus 72, so it's square root of 72. We looked at that earlier. It ends up being 6 square root 2, and that's a giveaway for letter A.
Right. Okay.
All right. Well, that is it for us for today. We're gonna pick up next week, whatever it is that you want us to work on. But hope you enjoy some time off, and have a great weekend.
Thank you. You too.
You're welcome. Bye now.
Bye.